Okay, so this is section 6.1, question 9. And this one's a little difficult also, Julissa. And I noticed that you had originally put negative 2, 1, 11, and I believe that's probably what was counted wrong. I'm not sure if that was your second attempt and you just hadn't checked this one. But you should have gotten an answer of negative 7, 5, 6. And we're going to go over how we got that. Okay, negative 7, 5, 6. Yeah. Okay, so once again, we're looking to set this up kind of like our goal. If we were going using the Gaussian method all the way, which we're not going to because it's going to take way too long. We're going to work it down to where we can solve using substitution. And actually, I'm going to make it where you can solve. Here's the deal. If you have a system of equations, if you have two unknown variables and they're the exact two unknown variables, then you need two equations to find the two variables. Here, if you have three, you need three equations to find the variables. So I'm going to work it down to where we have two equations with two variables, and then we're going to go through there and kind of move things around. But you'll see what we're going to do. So we set it up with 5, 4, 5, 15, 4, negative 2, 1, negative 32, and 1, negative 3, 0, because there's nothing in the x component, negative 22. And it looks like the first thing that I'm wanting to do here is I am going to replace row 3, and I'm going to get a 0 there in row 3. So I'm going to go ahead and I'm going to keep row 1 and row 2 the same. Let me change colors here. I'm going to keep row 1 and row 2 the same, row 1 and row 2 the same, and we are going to change row 3. Okay, you'll see that one changes. So I'm going to take row 2 and I'm going to multiply row 3 times a negative 4. We're going to combine those two rows. So I'm in essence saying row 2 minus 4 times row 3 will give me row 3. So I've got 4 minus 4, which gives me my 0. I've got negative 2 plus 12, because negative 4 times negative 3 gives me a positive 12. That's where my 10 comes from. And then I have 1 minus 0, which is just 1. And then I have negative 32 plus 88, which is going to give me a positive 56. Okay? Now, I decided that we are going to change row 2. So I'm going to try to get a 0 here in that spot in row 2. So I'm going to say 4 times row 1 minus 5 times row 2 to give me row 2. So that's going to give me 20 minus 20, which is 0. It's going to give me 16 plus 10, which is 26. It's going to give me 20 minus 5, which is 15. And it's going to give me 60 minus, or plus, let's see, I multiplied that out somewhere, I think. 32 times the 5 is going to give me 160. And then that's going to give me 220. Okay? Now, from this point, my numbers are getting fairly large here. Okay, so what I'm going to do, but I have found right here that I have row 2 and row 3 are down to two variables. Remember, this is x, y, z, and there's my constant. And so I've got two equations with the exact same two variables. So I have 26 y plus 15z equals 220, and 10x plus 1z, I'm sorry, 10y plus 1z equals 56. So these two right here stand for 26y plus 15z equals 220. And I've got 10y plus z equals 56. So what I'm going to do is I'm going to take this one right here. We already have z by itself. Pretty much I'm going to get z by itself, but I already have it to 1z. And I'm going to change that into z equals 56 minus 10y. Now I'm going to take that and I'm going to plug that into that 26y plus 15z equals 220. So everywhere I see a z in there, I'm going to plug in or substitute in 56 minus 10y. So that's going to give me 26y plus 15 times 56 minus 10y equals 220. That's going to give me 26y plus 840 minus 150y equals 220. I'm going to go ahead and combine that 26y and that negative 150y. That will give me 840 minus 124y, which equals 220. I went ahead and I subtracted the 840 to the other side. I'm attempting to get y by itself. That gives me negative 124y equals negative 620. And then I'm going to divide both sides by negative 124. When I divide by that 124, I get y equals a positive 5. Now I'm going to take that y equals 5 and I'm going to put it back into one of those two equations that I had right there. I chose to put it back into 10y plus z equals 56 because I already had just a 1z there. So I'm going to plug in 5 for y. So that's going to give me 10 times 5, and I'm right here. 10 times 5 plus z equals 56. So that's going to give me z equals 6. Okay. Now I'm going to take the y and I'm going to take the z and I'm going to plug it back into that very top original row, that original equation, which was 5x plus 4y plus 5z equals 15. So that's going to give me 5x plus 4 times 5 plus 5 times 6 equals 15. So that's going to give me 5x plus 20 plus 30 equals 15. That gives me 5x equals negative 35. Divide both sides by 5. X will equal negative 7. So we get a solution of negative 7, 5, 6.